Programming example for election results. It uses insertion sort and binary search algorithms, so we'll briefly describe these algorithms. The insertion sort algorithm sorts a list by moving each element to its proper place. Consider the following list. The length of the list is 8. The list elements list 0, list 1, list 2, and list 3 are already sorted in ascending order. The fifth element of array list is not sorted in ascending order. We need to move the fifth element of list to its proper location at the third element. So we will copy the fifth element of list into temporary memory space. And we will copy the fourth element of list into the fifth position, which is list 4. And the third element of list is in the fourth position, which is list 3. Copy temp into list 2. Now the element from list 0 to list 4 are sorted, and the elements from list 5 to list 7 are unsorted. We will repeat this process on the resulting list until each element is in its proper place. The following C++ function implements the insertion sort. From our discussion, we see that during the sorting phase, the array containing the list is divided into two sublists, elements that are sorted and elements that are unsorted and must be moved to their proper places in the sorted sublist one at a time. We use an index, first out of order, to point to the first element in the unsorted sublist. Initially, first out of order is initialized to 1. A binary search uses the divide and conquer technique. First, the search item is compared with the middle element of the list. If the search item is less than the middle element of the list, we will restrict the search to the upper half of the list. If the search item is greater than the middle element, we will restrict our search to the lower half. Consider the following sorted list of length 12. Suppose that we want to determine whether 75 is in the list. First, we compare 75 with the middle element, which is list 5. Since 75 is not equal to list 5, and it is greater than list 5, we restrict our search from list 6 to list 11, that is, from the 7th element to the 12th element of list. This process is repeated on the elements of list, from list of 6 to list of 11. Because we frequently need to determine the middle element of the search list, the binary search algorithm is usually implemented for array-based list. To determine the middle element of the list, we add the starting index first and the ending index last of the search list and divide by 2 to calculate its index. Initially, first equals 0 and last equals list length minus 1. The following C++ function implements the binary search algorithm. The function binary search has three parameters: the array to be searched, the length of the array, and the search item. If the item is found in the list, its location is returned. If the search item is not in the list, minus 1 is returned. The presidential election for the student council of your local university will be held soon. For confidentiality reasons, the chair of the election committee wants to computerize the voting. The chair is looking for someone to write a program to analyze the data and report the winner. Let us write a program to help the election committee. The university has 4 major divisions: Region 1, Region 2, Region 3, and Region 4. Each region will report results to the election committee separately. The input data is provided in 2 files. The first file, canddata.txt, contains the names of candidates in a random order. The second file, votedata.txt, contains the candidate's name, region, and the votes received in this region. There is 1 entry per line. A sample input from votedata.txt looks like this. The first line indicates that Mia received 34 votes from Region 2. The committee wants the output in this tabular form, with the names of the candidates in alphabetical order. The output must also display the winner of the election. For this program, we assume that 6 candidates are running, but this program can be modified to accommodate any number of candidates. Given the output requirements, it is clear that the program must organize the voting data by region. The program must also calculate the total number of votes received by each candidate and the total votes cast in the election. Further, the names of the candidates must appear in alphabetical order. Therefore, we need three different arrays. Array candidate's name to hold the candidates' names, array votes by region to hold the votes for each of four regions, and array total votes to hold the total votes received by each candidate. First, we will read the candidates' names from the input file, canddata.txt, into the array candidate's name. Once the candidates' names are stored in the array, we must sort it. Next, we must process the voting data. Every entry in the file vote_data.txt contains a candidate name, region number, and votes received by the candidate. To process each entry, we must find the appropriate entry in the array votes by region and add the votes received by the candidate. It follows that the array votes by region must be initialized to 0. After processing the voting data, we must calculate the total votes received by each candidate by adding the votes he or she received in each region. It follows that the array total votes must be initialized to 0. This discussion translates into the following algorithm. Read the candidates' names into the array candidate's name. Sort the array candidate's name. Initialize the arrays votes by region and total votes. Process the voting data. Calculate the total votes received by each candidate, and output the results. Next, we will list the functions to implement the 6 steps of algorithm. Function getCandidate'sName reads the data from the input file canddata.txt and fills the array candidate's name. Function sortCandidate'sName implements the insertion sort algorithm. Function initialize initializes the arrays votes by region and total votes to 0. Function binSearch implements the binary search algorithm. Function processVotes processes the voting data. Function addRegionsVote calculates the total votes for each candidate. Function printHeading displays the first 4 lines of input. Function printResults displays the remaining lines of output. Next, let us type the function definitions. The first function, getCandidate'sName, has 3 parameters, one corresponding to the input file, one corresponding to the array candidate's name, and one to pass the number of rows in the array candidate's name. This function reads the data from the input file canddata.txt and fills the array candidate's name. The input file will be opened in the function main. After a call to the function getCandidate'sName, the arrays will look like this. Next, we type the function definition of sortCandidate'sName. This function has 2 parameters, one corresponding to the array candidate's name, and a second to pass the number of rows to the array candidate's name. This function implements the insertion sort algorithm to move each element in the list to its proper place. After a call to the function sortCandidate'sName, the candidates' names will be sorted in alphabetical order. Next, we type the definition of the function initialize. This function has 3 parameters, one corresponding to the array votes by region, one corresponding to the array total votes, and one to pass the number of rows in the array votes by region. Note that both arrays will have the same number of rows. This function will initialize the arrays votes by region and total votes to 0. After a call to this function, the arrays will look like this. Next, we will process the voting data. For each entry in the file vote_data.txt, we will do the following. First, get a candidate name, region number, and number of votes for the candidate. Next, find the row number that corresponds to this candidate in the array candidate's name. This also gives the corresponding row in the array votes by region for this candidate. Then find the column that corresponds to the region number in the array votes by region. Finally, update the appropriate entry in the array votes by region by adding the number of votes for the candidate. Next, we type the definition of function binSearch. This function implements the binary search algorithm on the array candidate's name. Recall that a binary search uses the divide and conquer technique to search the list. Next, we type the definition of the function processVotes. This function has 4 parameters, one to access the input file vote_data.txt, one corresponding to the array candidate's name, one corresponding to the array votes by region, and one to pass the number of rows in each array. Declare the variables and input the candidate name, region, and number of votes. Call the function bin search. Update the votes of a candidate. Next, we type the definition of function add regions vote. This function must access the array votes by region and total votes. It has three parameters, one corresponding to the array votes by region, one corresponding to the array total votes, and one to pass the number of rows in each array. This function calculates the number of votes received by each candidate by adding the contents of each row in the votes by region array and storing the sum in the corresponding row in the total votes array. After calculating the total votes received by each candidate, the arrays will look like this. Next, we type the definition of the function print heading. Next, we type the definition of the function print results. In this function, variable largest votes holds the largest number of votes received by the candidate. Variable winlock holds the index of the winning candidate in the array candidate's name. And variable sum votes holds the number of votes cast in the election. The variables are initialized to 0. Calculate the largest vote and the location of the winning candidate in the array. Then calculate the total number of votes polled. Display the name of the winner and the total number of votes received. And finally, display the total number of votes polled. You can find the complete program listing in the book. A sample run of the program will look like this.